All right, so let's start. Is there any question before we continue? Maybe because I'm All right, so let's do a quick review. When we start working or learning about combinational circuit, we had a few rules. We say, okay, if number of input less than or equal 6, so what we will do, use the K-map, and the K-map, it's one table per output, and the size of the K-map is the number of input. And our example when we did the 2-bit adder. So if you will have adder, you will have A, you add it to B, and you will have the sum and the carry, correct? So you will have two input, and here we say it's going to be 2 output and 1 carry. Perfect. And based on that, we've been able to do the K-map, and that's how we do it. Then after that, we say, if the number of input is more than 6, okay, it's going to be a challenge to use the K-map. And that's what we start using the, bit slice approach, which is, you can do, you can build 1-bit adder, a second one, and just you use it as a carry for the second one, and connect them next to each other. And we said, to improve the delay or to reduce the delay, we use the look ahead approach. Okay, you start building a small one, then you extend it to 4, from 4 to 8, 16 to 32.
Oh, we're gonna be in here.
Yes. Can you write a note there?
Yeah, there's people there. I'll grab them.
Okay, please. All right. So that, and for another example, we did the comparator. And with comparator, during the class, we did the design from, the most significant bit to the least. And in the assignment, you did it from the least to the most, correct? So, and we say there is another approach when you have number of input is more than 6. What's the other approach we called it? Okay, we call it as the heuristic approach. Okay, can you tell me what that's mean from the word? So this approach, yeah, let's give it a few seconds. Is there any more? Did you guys write a note over there? No. You did not write a note? I will write a note. Yeah, usually that's the number, correct?
Yeah, Matt coming in.
Okay, let me just write a note very quick.
Why? He says that every time. Why don't we just start there? Like he's gonna let us go at 6:30 or move that class at 6:30? We'll find out.
All right. So just to repeat very quick, guys, try not to talk, don't focus with me. And if you can, stay away from each other, this will be perfect. First, let me change the font here. So as we mentioned before, in the combinational circuit, if the number of input it's less than or equal 6, we use the K-map. If it's more than 6, we'll use the slice approach. And the third approach, if it's more than 6, which is the heuristic approach. What that's mean? Okay, that's mean somehow somebody find a way without following a specific standard, a unique way to do the design, which you will not need. You don't have to use a K-map or any other approach. For example, I'll give you just an example, some of the heuristic way. For example, when you do multiplication, when you do 21 multiply 10, how you do that? You multiply the first one, 0 by 1, 0, 0 by 2, 0, yeah, 0, 1 by 1. So that's the way, correct? So somehow somebody came another method. He say, to multiply these two numbers, first what you can do, you multiply these two together. Okay. Then after that, you multiply these two, and you multiply these two and add them together. And finally, you multiply these two and you add them. Somehow he sat and find a way and worked. So he did not follow like, a standard or method. It just kind of, he explore and he invent this way. All right. So same thing. So that's another way. If there is a way, okay, to build or do a design for a combinational circuit, okay, without using the K-map, because our input is more than 6, that will be awesome. It's even, maybe it's going to be less complicated circuit. So I will give you an example. We have something called a priority encoder, and this one, I'll show you how. Simply this one, actually maybe I have it here. All right. So in this one, you will have, that's 4 to 2 priority encoder. You will have 4 input, I0 to I3. And for us, we will say, the highest priority is for the I3, and the lowest is for I0, correct? Now, what that's mean? That's mean if I have input like this, 0, 1, 0, 1. What is your output here? So since your higher priority is for I3, okay, what you will do first step, you will find all the input with 1. So which input you have has equal 1? I1 and I3. Then what is the highest priority in this case? I3. So what's your output will be here? Will be 1, 1. Okay. So in this case, you will find what is the high, or the input is equal 1. Then based on your higher priority, you select the output. I'll give you another example. If my input is 1, 0, 0, what's the output will be? 0. It's going to be 0, correct? It's going to be, first of all, this I1 here. So it's going to be 0. I'm sorry, it's going to be, okay, it's going to be 0, 0, the output. Perfect. Give you another example. If I do, okay, 1, 0, 1, what's the output will be? So it's going to be number 2, correct? Which will be 0, 1. Are we agree? All right. So now if we change that, I will say my highest priority is the I0. That's the highest. And that's the lowest. Okay, what's the output will be? Okay, first of all, we will see which one happened, which is I0. And can you please mute yourself? So what is the highest? What is the number 1? I0, I2. Now what is the highest? I0. So then we'll take the I0. The I0 is the highest priority for us. So what's the output will be? 0, 0. Okay. Give you another, can you please? Can you mute yourself?
Behind you. Box is behind you.
Well, let me find a mute for everybody. I'm not gonna mute myself, okay? All right, perfect. All right. So now what if all my input is 1, 1, 1? What's the output will be? It's gonna be 0, 0. Now if I change that, I say, that's the highest. and that's the lowest. What is my output? It's going to be 1, 1. Okay, you got the idea, all right? That's how you do that, you know, the high priority. Now, if you want to do the K-map for that, okay, let's design the K-map, all right? So, and let's, you know, let's assume, you know, the I3 is the highest. Perfect. I3 is the highest. All right. So let's take this row, the whole row here, and this row. What is your input here in this line? I3 equal 1, I2 equal 1. I'm sorry, I2 equal 1, I3 equal 1. Okay. And the I0, I1 is, you know, sometimes is 0, sometimes is 1, correct? Okay, but since is the I3 the highest and has input 1, what that mean? What's my output will be? It's going to be I3. Because if you have I0, I1, and I2, and I3, if this 1, 1, I don't care about those, correct? Because my output always will be on. So what this mean, since I3 here, you see the I3? It's 1 in the whole row. So it's going to be, always the answer is going to be 1, 1, 1. Because, you know, the 3 is 3, it's equal 1, 1. So you will have 1 here and 1 here. All right. Same thing in this block. All right. So what about this row? What is I3 equal here? So it's always 1. So we know it's going to be 1, 1, 1, 1, 1, 1, 1, 1. Perfect. All right. So let's clean that just to make it easier for you to see. Now, let's look at this one. And this one. Okay, what's I3? 0. That's always 0 in this line. What about the 2? It's always 1. All right. So what's the result will be? The result? It will be 1, 0. So it's going to be 1 here and 0 here. Okay. We'll have 1 here. I'm sorry. 0, 1, 0, then 1, 0, then 1, 0, then 1, 0. Correct? Perfect. What about this one? This one is a tricky little bit. All right. What about this row? Let's do cell by cell, maybe make it easier for you. All right. All right. So first, let's go first square here. Oh, let's leave this one then. Let's do this one. What's your I0? 0, correct? And I1? 1. Perfect. What about 0? 0, correct? So what is my output will be? I1. Correct? Which is 0, 1. So that's why we'll have here 0, 1. Okay. All right. So what you have here? I0 is 1, and this one 0. So that means it's going to be 0, 0. Correct? Okay. What about here? So we'll have 1, 1, and 0, 0. Correct? So which one? If you have this one and this one, which the highest priority? Is the I1, this one. All right. So it's going to be, the answer will be 0, 1. What about this square? It's going to be 0, 1, 0, 0, correct? Still, the answer will be 0, 1. Okay, what about this one? So we'll have, when you have 0, 0, 0, 0. There is no input, you know, there is no one of them is not equal 1. So what that's mean is not valid. It's not a valid option for us. So that's why you make this one, don't care. All right. Perfect. So that's how you fill out the table. Okay. Then just we have to write the equation. Okay. If we go down here, now you will not, you know, the point here, we're not gonna go in details, but we'll give you the idea. So still we've been able, because it's less than 4, we did the K-map. We've been able to do the K-map. All right. However, now how we want to guarantee the option 0, 0? I'm sorry, when all of them zeros, when all the input equals zeros, how we want to make sure you can exclude that? Because still, maybe somebody will give you input like this, correct? So, or maybe there is no input, it's just waiting. And by default, if there is nothing going in, there is no signal, we'll assume it's 0. So how you can do that? So that's why what you can do, you add all of them, or you OR all of them. When you OR all of them with 0, what's the result will be? The result will be 0, which is mean what you can do, that's going to be, a signal, we call it valid. All right. So if the signal here it's equal 0, what that's mean? You ignore this too, because there is not valid, it's not an option. So we added this OR gate, to help us to eliminate this case. So in another example, if your input 1, 0, 0, 0, this one is going to be 1. Then I will look at the output. I will take this output in our consideration. Okay. All right. So here I'm not here just for the idea. We've been able to use the K-map. It's a small, easy to design. The only thing, we add this small circuit. All right. Now the question for you: if I change that, if I do 8, 2, 3 encoder, how we can do that? Can we use the K-map when you have 8 input? No. Okay. You have to use the slice approach, and maybe the slice approach will not work here. Okay, it's not gonna, because we're not carrying, or there is no data moving from slice to slice, like the adder or subtractor or comparator. So somebody, after deep thinking, say, okay, let me design a circuit for that. Let me find a way without even using the K-map. So what they said, okay, let's do that. Let's, build a circuit similar like this. Okay, so this one is with the K-map. So he did the same scenario, and he add all of them just to see if it's valid or invalid. Okay, it's 8 input. So if you want to do the K-map, it's going to be a challenge. It's going to be a long K-map. So that's why we did not use the K-map, and that's why we use something called heuristic approach. And how that will work? Okay, here. So he said, okay, I have 7 input from I0 to I7. It's cannot go to a small circuit here. We'll call H encoder. And this encoder is this H encoder. Okay. What is the purpose of this encoder? All right. To make sure only one of the output here, one of them has only equal 1. Remember here, when you have I0 to I7, okay, maybe you will have something 1, 0, 1, 0, 1, 0, correct? Since I7 is the highest priority, then my output should be I6, correct? Are we agreed? Because I have to find all the ones first. Then since is the priority goes from the top to bottom, so that's the highest, then I will take the I6, correct? So the first step, he said, okay, let me make sure I build a small circuit here and make sure I have only one of the output equal 1 and the remaining 0. Correct? Perfect. So that's the thing. Then he say, no, after that, I will enter this input to something called symbol encoder, which it will give me, the highest priority. Okay, and it's going to be simple. Why? Because you will have only one input. If this line equal 1, okay, we know the output will be 7, will be 1, 1, 1. We know that, correct? Just we have to design a small circuit, simple circuit with a native K-map. So now let's start building the H encoder. Okay, so we have to find the H0 and H1 and H up to H7. And we said the highest is the I7. That's our highest. Let me make it up. Trying not to show you the equation. All right. So let's clean and clear. So let's repeat. What is the highest priority here? I7. Perfect. What is the purpose of the H encoder? To make sure only one of the output equal 1. All right. What is the purpose of the symbol encoder? It just to translate this output, to 3-bit, simply, since I know only I7 equal 1, it's easy. It will be easier for me to tell how much the I0, I1, I2. I will show you how. Now, a question for you. Can you give me when we can make I0 equal 1? How we can make sure this one is equal 1? We have to find a way to make sure high 0 equal 1 and the remaining equal 0. How we can do that? Simply. So what that's mean? We have to make sure only the I0 equal 1. All right. Okay. And anything else, okay, has 1, we'll find a way to eliminate that. All right. So how you can do that? By assuming I7 equal so if the I7 0, when you do I7 bar, what does mean? So that's mean here, we make sure that's always 0. All right. Then what else we can do? So I6 bar, I5 bar, I4 bar, I3 bar, I2 bar, and I1 bar, then I0. All right. So the H0 will be high. That's mean, my encoder will be, the output will be 0, 0, 0. When we make sure, okay, only the I0 is 1 and everything else, I'm sorry, I0 equal 1 and everything else 0. All right. So in this case, I will know I0 is the highest priority because the others by default will be zeros. Correct? So now, if I ask a question, what about H7? Can you give me an answer? Frozen. Laptop is frozen again. All right, so how? By can I do that? I have to reboot because for the Zoom. Guys, over Zoom, just I have to reboot my computer. Or I have to use the other one. Huh? It's recording, yeah, but I will not lose it, that's fine. So that's the trick, now it will be easy. All right, so until this one starts.
I'll make it bring with us. We have just make a bang with it. I'll be with the belly. We can start, you can start the H1. Right. Where's the line? Set up the office.
It's funny, I'm doing everything in my head to paint the UV as like an enemy in this case, but when they made every single point they made was. When the meeting was in attention. They said, "This isn't done. No meeting in 2 months." I'm sorry, I kinda can't argue with you.
No, I can't. I'm surprised they even allowed Christian, to be honest.
What, was there anything else in the first one probably?
I'm surprised they even approved the first two from the last time.
Everything is so